well. And I can show you what comes out of it. Okay, so if you turn over, hopefully you can't see my old writing. Through this, it's kind of hard to read for me, but I think you guys can see it. I'm actually, maybe you can't see this. I checked off the ones I want to do. I'm going to do examples 2 and 3, and then I'm going to move on to the next page and do one of the extra problems. This way, you guys have another 3 problems to try on your own, where you can test your knowledge of whether or not you understand these steps. Okay? So, let me go ahead and read this problem. And I like to record all the important information as I go. So I'm going to write down all the important stuff as we go. And maybe I'm going to need to underline some stuff. But I like to record it here so you guys can more easily read this later. It says, in the 80s, it was generally believed that autism affected about 6% of the nation's children. That is a national statistic. A national value. I keep saying statistic. So that's a parameter from the population. So that's going to be our P0. Some people believe that the increase in the number of chemicals in the environment has led to an increase in the incidence of autism. A recent study examined 384 randomly selected children, and found 46 of them showed signs of some form of autism. Is there strong evidence that the level of autism has increased? Okay, so there's a ton of information here, and including right here a significance level at the end. Okay, so we were given everything that we need to run this hypothesis test. So remember, if you go back to the notes, the 1 prop Z test requires the following information. We need to know the population proportion, the number of people who said yes, the number of people surveyed, and then below we'll have to write the direction of the alternative hypothesis. So we're going to need all that information as well as hypotheses. Okay, now this question right here really does help me write the hypothesis. Look at the wording. Is there strong evidence that the level of autism has increased? That's a greater than symbol. Okay, we believe the level of autism has increased. So it used to be 6%, 0.06. We now believe that it is in fact greater than 0.06, okay, because we believe it's increased. So over here, we're going to put 0.06, and then right below n, I'm going to draw in a greater than symbol, because in my calculator, I will have to select that. Now I'm looking for the number of people who had autism in the sample surveyed. So back up here, 384 randomly selected children. So that was my N. And we found 46 of them showed signs of some form of autism. That's X. Okay? So what we could do right now, if you wanted to check, remember that P hat is equal to X over N, right? So if you really wanted to know, we could figure out what our sample proportion is right now. So if we do that, just because we can, 46 over 384, our sample proportion is nearly 12%. Okay, that's 0.1198. Okay, so it's basically 12%. It is double what it was in the 80s. Okay, so we do have good reason to believe that we have in fact seen an increase in the incidence of autism. Okay, now the true test is to go to the calculator and we will receive a z-score and a p-value. Okay, so in your calculator, I'm going to show my calculator on the screen right here, okay? So what we want to do is make sure we go to the statistical tests. So stat, arrow to tests. You know I'm lazy, I arrow left for stuff. And we're doing a 1 prop Z test. That is number 5. Okay, so I selected number 5. I now have to choose, well, first I have to enter these 3 values and then select the appropriate hypothesis. So make sure you enter the proportion as a decimal, and then X and N are both whole numbers, okay? Then I can arrow to the right and select the appropriate alternative hypothesis before arrowing down and selecting calculate. And notice what pops up. A z-score, which I'm going to record to 4 decimal places because you know me. I'm going to set my calculator off to the side. 4.9336 is my z-score. And notice the p-value looks like it's 4, but go all the way to the right, guys. That's 4 times 10 to the negative 7. So 4 times 10 to the negative 7. And if you're not a fan of scientific notation, then I suppose we could write all of the 6 leading zeros and then stick a 4 after them, because that's what this number really is. All right, guys, final steps. We have our hypotheses. We put all the information into the calculator. We got our z-score. We know our p-value, okay? What I need to do is write a conclusion. And the only way we can do that is to compare this p-value to this significance level. So I'm going to write a little statement up here. I'm going to compare my p-value to my alpha level. Okay? So my p-value is 4 times 10 to the negative 7th. And my alpha level is up here, 0.05. Okay? So I have to look at these and compare them. I have to tell which one is larger. Specifically, I always like to start on the left for this inequality. I'm looking to see whether my p-value is in fact smaller or larger than my alpha level. This has only 1 0 after the decimal. This has 6. It is definitely less than the alpha level. And then I go back up to my notes and I check what this conclusion meant. When my p-value was less than my alpha level, the chapter 17 notes said that we reject the null hypothesis. So this is now wrong. So if I reject it, I can, in a sense, cover it up. And my conclusion is now that there is evidence to show the proportion of autism has increased since the 80s. Okay, so there is enough evidence to show the proportion of kids with autism has increased. Okay, so we want to write a little sentence. Remember, I told you in the notes that we have to write this conclusion in sentence form, and a nice, easy way to begin it, if we reject, is that there is now enough evidence. Remember, we rejected this. We want to show the change. What was the change we were supposed to show? An increase. So all of that is here in this language. There is enough evidence to show the proportion of kids with autism has increased. Okay. If you need to, pause the video. I am going to continue and do 2 more of these, okay? And I know they're lengthy. So I'm moving on to example 3 right here. It says, a company hopes to improve customer satisfaction, setting their goal to attain less than 8% negative comments. So look at that. True, great wording here. That's a less than symbol right next to the P naught. Okay? It says they surveyed a random survey of 350 customers, so that's our N, and they found only 27 that had complaints. That's X. Does this provide evidence that the company has reached its goal? Now remember, reached its goal, that is very wishy-washy. We go back up here, their goal is this. So we are hoping to show, in fact, that it has gone under 8%. All right, so back up here. We're going to have 2 things, right? We're going to first record what has to go in our calculator from the paragraph, okay? The alternative and null were written in the language of this paragraph, so I could actually go and write those before we fill this list out, because to me that's right there. Remember that your null always says there is no change. It must say that it is currently equal to 8%, but we are hoping to show that that percentage of negative comments has actually decreased or gone down, so less than. Okay, so now this was, the first example was a right-tailed test. Now we're doing a left-tailed test. Over on this side, I need P naught, I need X, N, and then I know that my alternative is going to be less than when I go to the calculator. I also know that P is 0.08 because, P naught, because they said they want less than 8. Now here for X and N, those were these numbers right here. 27 people still had complaints out of 350 people randomly surveyed. Okay, I'm going straight to my calculator. I will get a z-score and a p-value. Notice I was again given a 0.05 level of significance to make my conclusion here. Okay? So I'm taking my calculator out. Okay? I go to Stat, arrow left to Tests, and select option number 5. It retains all the information, so I have to change my p-naught to 0.08. My new X is 27, N is now 350, and we do need to change our alternative hypothesis to now say less than, because we believe that a decrease has occurred. And now I'm going to hit calculate. Okay. So our z-score is okay to be negative, negative 0.1970, and our p-value is 0.4219. Okay, so I am going to compare the p-value and the alpha level here and write a conclusion, and I'm actually going to take some space from number 4 to draw a picture because my handwriting is so big. But I want to just show you what the picture looks like for one of these. Or wait, hold on. Never mind. I'll do that for example 3. Okay? We can skip the picture for example 3 on this page. I'll do it for example 3 on page 11. So I'm going to now take this p-value and directly compare it to that alpha level. So my p-value compared to my alpha level. I always like to rewrite them so I can make a true number sentence underneath. This is 0.42 compared to 0.05. It is, in fact, larger than alpha, which means I have the opposite conclusion I did up here. I now fail to reject the null. Okay? This is a different conclusion than before. I now don't have enough evidence to say the comments went down from 8%. And did you hear the language that I said? I never said they still equal this. I said I don't have evidence to show this. So I like to start with, there is not enough evidence to show the proportion of negative comments is less than 8%. So I don't have evidence to show the change. Remember, I never want to claim this was true. If we want to, just the reminder that we're always allowed to check what our p-hat was. And in fact, another reminder, if I go back onto my calculator, p-hat is actually given to me here. And in this case, it's telling me that it's 0.077. Okay, so my actual proportion of negative comments was 7.7%. So I just want to be clear about what we just were able to see. Okay, let me explain. My sample had 7.7%, which is slightly less than 8%. However, I did not have statistical evidence, like a tiny p-value, to really show that that number had decreased. Okay, so we're trying to have scientific evidence or mathematical evidence here. And that does not exist in this case because these two numbers are just still too close together. Okay, I am going to move on to the next page. So I've now completed these two examples. So that's example 2 and example 3 on page 10. I'm going to move on to page 11. So I'm flipping this over. And out of the sake of choosing different examples, I now want to do example number 3 on this page, okay? This page does feel as though I will have enough room to draw a picture as well as do the test. So let's read this through. I'm going to fill in what I already know I need, okay? This is still chapter 17. Okay, so it's still going to be a one prop z-test. I need p naught, I need x, I need n, and underneath I'll write the direction of the alternative. And then I know that I will also have a null and alternative hypothesis. And honestly, I know they both start with p. So, and this one has to say equals. So far, this has all been true. Okay, so let's go ahead and read and we can fill these all in. First percentage given is typically p naught. So let's make sure that makes sense for this example. According to a survey, 85% of American adults eat salad at least once a week. A nutritionist suspects this percentage is incorrect. Okay, so that does not say greater than or less than yet. So let's see if that information is given or if this is implying we have to test not equal to. She conducts a survey of 200 randomly selected Americans. I'm just going to stop there. The randomly selected people we survey are a number of people who are in the sample size. And it says 165 of them eat salad at least once a week. That's the people who said yes. So the only number that we're left to find is p naught, and that's going to be this 85% that's given. So we're going to convert that into a decimal like we've been doing for our proportions. Now that means this number goes here. Okay, our job is to figure out what symbol goes here, and then we put the 0.85 right next to it. It says, is there sufficient evidence to support her claim? And her claim, or the nutritionist, her claim is just that it's incorrect. So her claim doesn't have a direction, which means our alternative cannot have a particular direction. We have to test not equal to. So that means when we go into our calculator, our final job here in this list is going to be to select this symbol. We'll get a z-score and a p-value, and then down here, I'm going to compare the p-value to the given alpha level. Now look at the alpha level is now 10%. So this is what I'm going to be filling in now to do my comparison. So I take out my calculator, stat, arrow left to tests, select option number 5. It's the one prop z-test. In p naught, I put in 0.85. That's the current percentage of people who eat salad at least once a week. In x, I put in 165. In n, I change that to 200. And now I'm going to select not equal to because I want a two-tailed test. And now I'm going to go down to calculate. Okay, so right now I'm going to record my information, just move this over, negative 0.9901, and my p-value is 0.3221. So my p-value is 0.3221, and that is definitely larger than my alpha level, which means that I am going to have to fail to reject H naught. Okay? Just like our last problem, this implies that we do not have evidence to show a change. So, there is not enough evidence to show the proportion of American adults eating salad at least once a week has changed. I guess I could also use the term is incorrect, right? Because that's the term that she used in her problem. Okay, the final thing I promised I would do for this picture is really show you what the output is in terms of an image, okay? So the z-score we got was negative 0.99, which is one standard deviation away from the middle, so it's pretty close. So this is the z-score that we got, okay? But if it's a two-tailed test, like we chose, the calculator is actually smart enough to then graph another z-score on the other side at the exact same value and shade in both directions away from the mean. Which means that this value right here is 0.3221 over 2, and this is the other half of my p-value. So I've got my two z-scores. I shade away from each, and that's another reason why this p-value is so large. If we could have determined a direction for how far away we might have been, our p-value would have been smaller, okay? So a direction for how we might have eaten more or less than the amount she suggested. That's what I mean, all right? So just what this means is our sample proportion, 165 over 200, is just too close to 85% for us to claim a change. We do not have the evidence to show that there is a difference here. Whew. Okay, that concludes my Chapter 17 examples video. I really hope that that can be of use to you trying to learn these concepts, and especially in lieu of going to class this week for Math Awareness Week. Thanks for watching.